Hi students, welcome back to the channel. Today we are going to learn about 8th standard science, matter around us part 1. In this video, we want to learn types of matter, symbols of various elements, physical properties of metals, non-metals and metalloids. In the universe, all manifestations, phenomena and evolution of life are caused by matter and energy. The various objects which exist around us are made up of some kind of matter. For example, glass tumbler can be seen, agarbatti burning can be recognized by its smell, whereas wind blowing can be felt. So next we move to matter definition. Anything that has mass and occupies space is known as matter. Matter may be invisible to the eye. All matter is composed of discrete tiny particles called atoms. You know very well about the states of matter. So the matter is classified into 3 states. Number 1 is solid state, liquid state and the gaseous state. Examples for solid state: wood, stone, sand, iron, clock, hammer, pliers, etc. Examples for liquids: fresh water, juices, milk, soup, etc. Examples for gaseous state: oxygen, nitrogen, carbon dioxide, steam, fire, evaporation, clouds, etc. Then next we move to how the matter is composed. All matter is composed of atoms and a group of atoms bonded together called molecules. Substances are made from more than one type of atom bonded together are called compounds. The compound makes the matter. Matter in any physical state is composed of smaller particles such as atoms, molecules, ions. Now we move to what is atom. An atom is the smallest particle of an element which exhibits all the properties of the element. It may or may not exist independently but takes part in every chemical reaction. Atom is composed of protons, neutrons and electrons. Then second one is molecules. Atoms of the same element or different elements combine to form a molecule. A molecule is the smallest particle of a pure substance. For example, in water, 2 hydrogen atoms combined with 1 oxygen atom to form a molecule. In ammonia, 3 hydrogen atoms combined with 1 nitrogen atom to form a ammonia molecule. In carbon dioxide, 1 carbon atom is combined with 2 oxygen atoms form a molecule. In hydrogen peroxide, 2 hydrogen atoms combined with 2 oxygen atoms to form a molecule. Then third one is ions. Atoms or group of atoms having a charge, that is positive or negative, they are called ions. An atom contains plus charge, that is called cations, and minus, that is called anion charges. So next we move to summary. So nitrogen and magnesium are examples for an atom. Water is an example for molecule. Magnesium and hydroxyl ion is an example for ions. Next we move to symbols. A symbol is an image, object, etc. that stands for some meaning. For instance, a dove is a symbol of peace. Similarly, the plus symbol denotes addition, the minus symbol denotes subtraction, etc. In the same way, in chemistry, each element is denoted by a symbol. Writing out the name of an element every time would become too troublesome. So, the name of an element is represented by shortened form called as symbol. Let us learn the brief history of symbols of elements. The first symbol is Greek symbols. The symbols in form of geometrical shapes were those used by the ancient Greeks to represent the 4 basic elements around us, such as earth, air, fire and water. Second one is Alchemist symbol. In the days of alchemists, the different materials that they used were represented by the above mentioned symbols while they tried to change this less valuable metal into gold. The process was called alchemy, and the man who did this work were known as alchemists. The next one is Dalton Symbol. In 1908, John Dalton, the English scientist, tried to name the various elements based on these pictorial symbols. These symbols are difficult to draw and hence they are not used. It is only of historical importance. Next we move to Berzelius symbols. In 1813, John Jacob Berzelius devised a system using letters of alphabet rather than signs. The modified version of Berzelius system follows under the heading System for Determining Symbols of the Elements. So next we move to present system for determining symbols of the elements. Number 1. The symbol of the most common elements, mainly non-metals, use the first letter of their English name. For example, capital B is a symbol for boron, capital C is a symbol for carbon, capital I is a symbol for iodine. Number 2, if the name of the element has the same initial letter as another element, then symbol uses the first and second letters of their element name. First letter in uppercase and the second letter is in lowercase. For example, Ba symbol for barium. Bi is a symbol for bismuth. Number 3. If the first two letters of the names of elements are the same, then the symbol consists of first letter, second letter or third letters of English name that they do not have in common. For example, Ca is a symbol for calcium, Cd is a symbol for cadmium. Number 4. Some symbols are used on the basis of their old names or Latin name of an element. For example, the sodium is derived from the Latin name natrium, symbol is Na. Potassium is derived from the Latin name kalium, the symbol is K. And the iron is derived from the Latin name ferrum, the symbol is Fe. Number 5. Some elements are named using name of country, scientist, color, mythological character and planet. For example, americium, the symbol is Am. The name is derived from the country America. Number 2, Nebulium, symbol is No. The name is derived from Alfred Nobel, the scientist. Mercury, Hg. The name is derived from god Mercury, that is come under mythological character. Plutonium, Pu, the name is derived from the Pluto planet. So next we move to how to write symbols for a given element. Two important rules should be followed when writing the symbols of elements so that there is no confusion. Number 1, the first letter of an element symbol is always a capital letter. For example, capital N for nitrogen, not small n. Number 2, if there are two letters in the element symbol, the second letter is always a small letter. For example, CO for Gopal, not for capital C, capital O. Next we move to metals and non-metals. The wealth of a country is measured by the amount of gold in its reserve. These days, metals and non-metals are used for making tools, machines, car, utensils, etc. For example, copper, lead, tin, nickel, steel, zinc. Similarly, the common non-metals used are nitrogen, oxygen, hydrogen, carbon, sulfur, phosphorus and chlorine, etc. An element can be identified as metal or non-metal by comparing its property with the general properties of metals and non-metals. In doing so, we find that some elements neither fit with the metals or with the non-metals. Such elements are called as semi-metals or metalloids. For example, silicon, boron, antimony, germanium. So first we move to metals. Examples for metals: iron, copper, gold, silver, etc. Physical properties of metals. Number 1, ductile. Ductile means metals can be drawn into thin wires. Number 2, malleable. Malleable means metals can be hammered into very thin sheets. Number 3, good conductors of electricity. Number 4, good conductors of heat. Number 5, shiny. Number 6, high melting point and boiling point. Number 7, high density. Number 8, strength. So first, melting point. Solid at room temperature. For example, mercury is used in thermometers. Density. Generally, metals have high density except sodium and potassium. For example, aluminum is used in aircrafts because of low density. Number 3, thermal conductivity. All metals conduct heat well. For example, aluminum and stainless steel used in cooking pans. Number 4, malleability. Metals can be bent into different shapes. For example, car bodies made of flat steel sheets. Next, strength. Some metals are strong, zinc, arsenic, and antimony exceptions. For example, iron is used to make girders and reinforce concrete. Next, electrical conductivity. All metals having good conductors as solid or liquid except bismuth and tungsten. For example, copper and aluminum used to make electrical wires. The next one is physical properties of non-metals. Non-metals are usually lusterless, that is dull, except graphite and iodine. Number 2, they are brittle if the non-metal is solid. Number 3, non-metals are bad conductors of heat. Number 4, they are bad conductors of electricity except graphite. Number 5, they are non-sonorous, that is, they do not produce a metallic clink sound. Of the 24 non-metals known today, 12 are solids. Example, carbon, silicon, phosphorus, sulfur. One is a liquid, that is bromine, and 11 are gases. Example, hydrogen, nitrogen, oxygen, fluorine, chlorine, helium, neon, argon under ordinary conditions. The next we move to uses of metals and non-metals. First we move to metal uses. Number 1, iron is used for making bridges, engine parts, iron sheets and bars. Number 2, copper is used for making electrical wires, coins and statue. Number 3, silver and gold are used for making jewels in decorative purposes and photography. Number 4, mercury is used in thermometers and barometers because of its high density and uniform expansion at different temperature. Number 5, aluminum is used in electrical wires, cables and in aerospace industries. Number 3, lead is used in automobile batteries, X-ray machines. Number 2, non-metals. Number 1, diamond, a form of carbon, is used for making jewels, cutting and grinding equipments. Graphite is used in making pencil lead. Number 2, sulfur is used in the manufacturing of gunpowder and vulcanization of rubber. Number 3, phosphorus is used in matches and rat poison, etc. Number 4, nitrogen is used for manufacturing ammonia. Number 5, chlorine is used as a bleaching agent in sterilizing water. Number 6, hydrogen is used as a rocket fuel and a hydrogen flame is used for cutting and welding purposes as well as a reducing agent. Next we move to metalloids. Metalloids have the properties of both metals and non-metals. Physical properties of metalloids. They can be shiny or dull. Metalloids acts as a semiconductors. They conduct heat and electricity better than non-metals but not as good as metals. Silicon, for example, appears lustrous but is not malleable nor ductile. It is brittle, a characteristic of some non-metal. It is a much poorer conductor of heat and electricity than the metals. For the next video, we will see compounds, classification of compounds, uses of compounds in matter around us part 2 video. If you have any doubts and suggestions, give your feedback to the WhatsApp group. Thank you. Have a nice day.